Thank you, Eva. Hi, guys. So thanks, Eva, for the presentation, and I'm sharing my screen. So before we start, a little disclaimer: I have quite a weird setup here because I couldn't use our webinar casting software using Linux. So I have a virtual machine, and it's kind of dodgy. So there is a non-zero chance that everything just freezes at some point, and then I hope Eva will cover and will keep you occupied until I restart my system. So the other consequence of this is that despite all our best efforts, there is no way that I can make my web camera work. So you're not going to see me, and I'm not pretty, so that's probably a good thing. Okay, so I have some assumptions before starting the webinar. So one of them is that all of you guys know what RDF is, which was verified by the poll, which makes me very happy. The other assumption is that you are at least a little bit familiar with the Ontotext tooling. This is the mostly GraphDB and SPARQL and the whole semantic web philosophy. And my plan today is to walk you through a kind of a pretty basic data integration scenario using our tooling, which at first glance might seem simple, but actually it has all those little pitfalls that that any data manipulation and RDF conversion scenario has, and we'll walk through them one by one to see how we can handle them with the tool. So I'll first show the OntoRefine part of the Ontotext Refine, which is a tool for visual data exploration and cleaning. Some of you, I regret we didn't have a poll if you're familiar with OntoRefine, but I imagine some of you are, most of you are. It's an open source tool for data manipulation, which is the basis of Ontotext Refine, which is our wrapper tool around it to produce RDF. So I'll first show you OntoRefine and how we can use it for data exploration and cleaning. Then I'll demo the visual RDF mapping UI, so a visual interactive way to produce RDF, and why we like it and why we think it's useful. Then how we use Ontotext Refine as a virtual SPARQL endpoint to actually use the RDF that we have mapped, and then showing the one new feature that we have added to the tool, which is the command line interface, which allows us to automate tasks which we have first which have spec'd and created using the visual mapping interface. So the actual task that I'll be performing is actually, it's a real data integration task that we are doing right now, which is converting the information from the Ontotext blog to RDF, because we want to build something called Ontotext knowledge graph, which has all our marketing and educational materials at one place, produced formatted in RDF, so that we can use it and we can basically apply our technologies to our own content. That's the idea. And so here I used one of the cases there, which is the blog post on the Ontotext website, which I will convert to RDF. So in order to do that, it's simple. I won't scrape the website because I have access to the website backend, which is a WordPress, and I can export the data in CSV tabular format, and then from that I will produce RDF according to a predefined model. Quick word on my setup. So I have a really stock Ontotext Refine, which I just downloaded as my whole setup because I'm using a virtual machine, that I just downloaded from the Ontotext website. So Ontotext Refine is free to use, and you can download it, and it's very easy to run and install. And it looks like this. And it is bone stock. So this is the default address. It's at localhost 7033. I also have GraphDB free, latest version that I downloaded from the website. So GraphDB looks like this. Again, It's at the default address, localhost 7200. And inside it, I have created a repository, which is called the OTKG, which stands for the Ontotext Knowledge Graph, and there is almost nothing inside. Ontotext Refine knows where GraphDB is, which is accessible from the setup tab, which is quite simple. I just told them, okay, GraphDB is there, and the repository that I'm going to use is the Ontotext Knowledge Graph repository here. So it knows where GraphDB is. And that is all. So data that I'm going to be manipulating is in this CSV file, which I'll load directly into Ontotext Refine. Now like this. And it asked me several questions, which are your basic import questions. What my data looks like. Is it comma separated, tab separated? Should I ignore some of the first lines, and so on? I can also handle quite a bit of other formats. So you can see I can handle JSON files, I can handle XML files, Wikitext, and all. It has a whole lot of functionalities. This comes directly from OntoRefine, which is an open source tool. As I said, most of you know it. It has quite an active community and has a lot of nice and funky features, some of which we'll see today. Okay, so here, nothing exciting for now. It's a tabular output of the Ontotext blog. It has 257 rows and has a number of columns. So the target RDF shape I have in this file here, which I'm very grateful because somebody has done before me the work to properly model the resulting RDF. So this is an entity relationship diagram. If you're familiar with our work here at Ontotext, you know we use them quite a lot. So this is a definition of the model. It has the different objects, which here one is a blog post, the other one is the images, persons, and some static stuff here. It's modeled in schema, so the prefix S column stands for schema. It's just easier to read. This is why we use the schema prefix and not the S two points prefix. And so we use schema to model our data. Here we see the different operations that we need to perform on the different columns. And as you can see, some of them are static. For example, the type. These ones mean that we'll take the value out of one of the columns. Sometimes we have to apply, of course, we have to apply some data type transformations. For example, the date publish, obviously we need to have it into a proper RDF data type. Here also we want this thing to be in RDF HTML data type. Some need a little bit more transformations. For example, this thing here has to be converted to a URI. Here also it has to be converted to a URI, and at the end we have some stuff that needs to be split, but you'll see this in the data. So this is the target data model. Now let's see what the data looks like and how easy it will be to do this using the tool. So first of all, before we look at the data, as anybody familiar with semantic technology knows, most important thing is to think what our identifiers are, because this will be the subject, the subject URL in our triples, and it will kind of guide the whole process. So here in this diagram, we can already see that we have 5 URIs to worry about. So the main one is the one with the blog post, and fortunately, we can see it says permalink, which is actually, let me show the Ontotext Refine, which is actually already a URL in a column. So this kind of has our work cut out, which is pretty good. Let's see if it resolves. Yeah, it will even resolve to the actual blog post. Amazing. So this one we're good. Then the next one in our model is this one here, which is the author of the blog post. So schema blog posting, schema author, and this thing. And here we see that our data model asks for a mail to URL. So this is basically a concatenation with mail to 2 points and then the author email. So this is pretty straightforward. We'll see how to produce that. Then this one and this one is kind of straightforward. This is a static, so the publisher is always going to be Ontotext. We're just going to put it there statically. Primary image of page is image featured, which is another URL column. And this one here is a little bit more tricky because it has split. So this one we will need some more targeted processing because we have multi-valued fields which are part of a single cell. This is something that we see very often, all of you know, and it's kind of tricky to handle every time. Okay, so let's see how this thing looks in OntoRefine. Okay, so we saw the permalink column. I'll zoom in a little bit. Also, if there, again, disclaimer, if there is a problem with if you don't hear me or if you don't see something, please write in the chat, and then Eva will take care and communicate this to me because I cannot read the chat and present at the same time. Okay, so here is the permalink is okay. Let's see the other columns that are interesting for us. The other one was image featured. So here, yes, again, we have a URL. We're good to go. Both the username and author email we have here, but we don't have the mail tooling, so we'll have to create it. I'll show you how to do this. And then we have what we have. We have slug and the date. But first, let's see some of the features that OntoRefine, the open source tool on which Ontotext Refine is based, has. It has some very nice features for data exploration, which is based on facets. So let's explore the author email field, for example. Oh, no, let's explore first one more basic field. For example, the status field. There was a status field somewhere. I have a note here. Where is my status? Here is the status field. So let's see what kind of statuses there are. I created a facet, clicking on the column, and here I have the facet, and I can see that I have only 3 statuses. They look good: publish, private, and draft. I can use the facet field to filter out my data, which is very, very useful. And I can explore this way to see what the unique values are. So the status field is, I guess it's clear. And let's explore one of the other fields, which is the author field, to see what's going on there. So I can do a text facet and see all my individual authors here. We can see that there's a bunch of them, and I can order them by cardinality. So I can see which is the most prolific author is this colleague here, and then we can see in descending order the number of posts by each author. And I see this thing here, which I know because I discussed with my colleagues, which is kind of weird because it's a private email. See, Joy, it's not an Ontotext email. So I asked my colleague, what is this about? And he said, yeah, this is one of our colleagues who used the private email. But let's fix this first, and let's fix this and not so it's not part of the data. And I can do this here quite easy. So I know that it is this colleague here, which has used her private email, and I'll just merge the two. But first of all, I want to see if it's the only field that I'll need to merge. So let's see how this goes. Okay, I have filtered by this, And I can see the author username is also a weird one, so I'll put a facet here. And the author first name is weird because it says GraphDB. I don't want GraphDB, I want the real person. And the author last name says something QAMP, whatever. And it's all. Here I want to focus our attention on how the facets are interconnected. So here I filtered by this email, and I can only see one value in the other facet. So they're connected by an AND Boolean operator or operator. If I exclude this, I see all the people. And so, for example, if I click on this email here, I can see the first name and the last name of the person, which is quite useful to quickly get a handle on how messy or clean the data is. Are there some duplicates that need to be handled, or is everything okay? So let's go back to our personal email, and let's fix first the other field. So here I'm going just to copy this, and I know that the username should be this thing here, and I'm going to fix it directly in the facet, which is very useful because I don't have to go search in the data. I can just fix it here, and I'm good to go. And it fixed it in the table. So here, again, this is the first name. So the first name, Kirkana, with a capital letter, and the last name is Nikola with the capital letter. Okay, now that I fix this, I'm going to fix the email also. Okay, so I fixed 30 rows of my data quite quickly. So let's see if there is other messy stuff here. So let's see the author username. Do I know all these people? I kind of know my colleagues. I know all these people. It looks good. Here it looks good, but I don't know this guy, this hype thing. I don't know what the hype thing is. So I'm going to click on it and have a look. And it says something. What does it say? It says uncategorized. It has a weird date. It has test only. Please ignore. So let's ignore it. The easiest way to ignore something when I produce RDF is to delete its URI, because if it doesn't have a URI, there won't be any triples for it. So the easiest thing here, I'll just do this, and I'll delete the permalink, which means that I won't see this in my data because there won't be any value to produce for URI. So let's do this. Okay, very good. Let's reset, remove all the facets, see some other data exploration. Always a good idea to have a look at the dates, because as you know, dates can be formatted in many different ways. And when we're producing RDF, we want them all to be normalized. So just have a quick look at the dates. They look okay, or in the ISO format. So here we're good to go. Okay, let's see on something else. Meta description or something, or the tags. Let's see how the tags work. There were some tags here. Yep. Let's see the facet here. So here we see that actually we have multi-valued fields, which are separated with a vertical line, which is something that we'll have to handle. Okay. So now that we're kind of good to go with the data, we like how it looks. We'll start producing some RDF out of it. So first, in order to do that, we need to map our data. So let's go back to the model. We'll need to create all this stuff exactly according to the model. And this, in order to do this, we have a RDF mapping visual user interface, which is accessible here, edit RDF mapping. And it allows us to visually create the RDF mapping. So we have, for those of you who know OntoRefine and who have used it to contribute to Wikidata, I know that many of you out there are contributing to Wikidata every day, and that's a good thing. We were inspired by the Wikidata mapping interface. So here we have, these are the columns, correspond to the columns in our table, which we can drag into different positions, so into subject, predicate, and object position, and in this way, iteratively and interactively construct our triples. But let's see how this actually works. So which is the first triple that we want? Let's see the model. Again, we see the model. So the first is, let's construct the URI and give it a type, RDF type blog post. So this, we need the permalink, drag it here, and here we have a dialog which says, okay, well, what's the value? What do you want me to do with this? And I'll tell him, okay, here we're good. This is just a raw RI, and don't do anything with it. So let's see, a raw RI. Then we say that this is RDF type, so and schema blog posting. Okay, we're good to go. We have our first triple. And something which is very important when you do RDF, we want to verify if the mapping is okay. So we have a preview mode, which actually shows how the data will look. So we see the value from the first row of the table, and we know how it looks. Okay, let's continue. Let's see what else do we need in our model. Where is my model? It's gonna work. Look, where is my model? If I close my model, I'll open it again. Okay, so then let's add the abstract. So abstract again, as you can see here, abstract is just part of the data, so this will be easy. And here we can directly continue and say that schema abstract is, and I can even use a shortcut with the @ symbol, refer directly to the column, which is except, and it has the data type literal. Next, what do I need? Additional type. Okay, this one is interesting. Additional type blog posts. But here we can see that blog post actually is a static. So I'll put a static constant URL. Additional type. And here I will say that it is a content type blog post. Content type blog post with an underscore. So here I have to tell him that this is an IRI and that is a raw RI. So it doesn't need to concatenate a prefix to it. Let's have a look how this looks. It looks kind of okay, but not 100% okay, because here it says example.com. It shouldn't say example.com. This is because I haven't changed my base. And let me just get my base from my prefixes file. My base should be this thing. And I'm going to add it here. Okay. Let it reset. Okay, now it looks good. Ontotext graph blog post. Okay, I don't want to leave the webinar. Okay, next. Let's see something. Date published. So I'm going to add a date published, which is schema. And the date, and here I have to tell him that it's not a literal, that it is a literal, but it has a data type. So the data type is XSD, it knows it, XSD, and I even think that it has a autocomplete function. So it's XSD date. Okay, and we're good to go. Let's see how it looks in the preview. Looks perfect. This is how a date should look in RDF. Okay, I won't go through all of these because, as you can see, they're quite a bit. Let's look at how this is going to work. The scheme author with the mail to. So in order to create a mail to URL, I'll go back to my data. So I'm going to save my mapping and I'm going to close it. I'm going to go back to my data and tell him that I want a mail to URL. It's very easy. I'm going to get my email and I'm going to say create a new column out of this column. And OntoRefine has a quite powerful expression language called the general refine expression language, which allows me to do stuff like this. So concatenate mail to the value. It has a preview, and I can now see. I can now create my mail to URL, which I'll call author URI. Author URI. Okay, we're good to go. Now I can go back to my mapping. And then let's add scheme author. I think this is what the model says, scheme author, right? And my scheme author is author URI. How does it look? Doesn't look good because it's not a, it's a literal in quotes. I don't want it in quotes. I want it to be a URI. And now it's a URI. It looks good. Okay, I go back to my configuration. And now I can use a quite neat feature that we have, which is called nested triples, and which allows me to continue and to actually use something that's in the object position here as subject position. So I use this little arrow here, and as you can see, it creates this greenish block, which allows me directly to chain predicates onto this URI, which here will be in the subject position. So let's see what we need here. We need to say that this is a person. So a scheme of person. Okay. What else do we need? Scheme first name, I think. A given name. Scheme a given name, and I can refer to my column, which the column was author first name. Schema family name and author last name. And I have a schema name, and you can see here actually it tells me to concatenate the two. So let's see how we can do that. Schema name. Here I have grel, which is the same expression language, which I can use directly from here. And here there is a syntax that we have to learn, which is like this. Cells. So refer to the cell, which is author. What was it? Author first name. Value. Okay. I have a preview, which is very useful, which I'm going to concatenate to the author first name, author last name value. Okay. It looks almost as it should. It doesn't have a space, so let's add the space. Concatenate space symbol and plus, and it looks perfect. Okay, this is literal, and we're good to go. Let's see the preview of our data. You can see it is good RDF. Okay, now the more tricky part. Let's go back to our main object. And I have this keywords and it says split the tags. Let's see how I'm going to do this. Okay. Schema keywords. Did it work? Schema keywords, yes. And here, I'm going again to use the graph expression, and I have split function in graph, which is split. Sometimes split what's in the tag column using the vertical pipe as a separator. How does it look? It looks perfect. It has a preview, and it showed me what the result is. And I'm very happy with the result. So I tell them that these are going to be literals, and I'm good to go. And the preview shows me in RDF how it's going to look. So remember, comma set, when you use the comma in Turtle, it means that we have more than one object with the same subject and predicate pair. Last thing is this thing here. So I have multiple images. And so I need to split the image URL column, again using the vertical pipe, and just attach the blog post to the image. How am I going to do this? Image. Here again, grow split cells. Let me image URL. This doesn't look good because I don't know the name of the column. It's with a capital I. Cool. So I have my individual images, and in this case, because this is going to be an array, I tell it's not a literal, it's an array. Let's see how it looks. It looks good. We see we have the symbols that indicate that the value here is an array. Okay, I'm gonna save my mapping. Mapping looks pretty good. Cool. So now that I'm happy with my mapping, what can I do with it? I can directly look at the resulting RDF, clicking on the RDF button and saving it to disk. Let's see how it looks. It looks pretty well, actually. It is valid RDF, and browsing through it, I see my person triples. I have the keywords which are properly separated. Let's see if I can find something with multiple images. Okay, this thing here, images are properly separated, so it looks pretty good. So I can get directly my resulting RDF. But maybe that's not what I want to do. Maybe I want to do some more interesting processing. And for this, I have the SPARQL button, which here I can open the GraphDB instance. And I have a pre-constructed SPARQL query, which corresponds to my mapping. So here I'll take a moment to actually explain what's going on. And I have a very neat diagram here. Just let me find my working folder. I have a very neat diagram here that explains what's going on. So I have my GraphDB instance with a SPARQL endpoint. I have the GraphDB workbench, which is the web interface, which is this thing here that I'm actually looking at. I have my Ontotext Refine instance, which has its own virtual SPARQL endpoint, which corresponds to the RDF version of the tabular data that's in OntoRefine. And when I clicked on the SPARQL button, it created a federated query on the GraphDB endpoint, pointing to the OntoRefine instance. Now let's see how this looks in GraphDB. It looks like this. So magic happens in the service clause, in the where clause, sorry. So I have a service clause which says where the virtual SPARQL endpoint is, and you can see it has the URI of my OntoRefine, which is localhost 7333, which corresponds to this. It has the project ID of the project that I just created, and here I have the mapping in SPARQL format. So all the stuff that I did here, that we just did, all this stuff here is represented in SPARQL format. So here is, for example, the clause which says apply the XSD data type to the value in the date call. Here is where is the clause where I concatenate the name? I don't have the name. Schema name, all name, where is the all name? All name, well, here. Here I have this expression, which is actually a kind of a weird triple because I have this, the Grell expression in the subject position, but basically it says, okay, take whatever I have in these two columns, concatenate it, and then put it in this variable here, and then I can use the variable in the construct part. Here is the split. In the splits, I had two splits, one concerning the images, one concerning the keywords, and all this is rendered as a SPARQL query. This SPARQL query, also the mapping continues in the construct part, so I can see I want a blog posting with this structure, author with this structure, and keywords with this structure. So running the SPARQL query on the GraphDB endpoint will construct and will produce exactly the same RDF that I got clicking here. So remember, I got some RDF out of the tool clicking here. The same one I get in my GraphDB endpoint coming out from the Ontotext Refine virtual endpoint. So I know it's a mouthful, but bear with me. And I can see it looks cool. It looks okay. And also I can do quite interesting stuff. So remember, this is querying a virtual endpoint, but it doesn't say that I don't have already stuff in my knowledge graph. So for example, I might have, let's say I have a taxonomy that encodes information about the topics that I get normally in the tags, but I have it as RDF. So I have actually constructed something like this, which is very, very simple. It's a toy. It's a toy. I've constructed one concept that said, okay, the concept of reasoning has this URI. It's my first tag, and it has this. It can be referred to by these two labels. It can be called RDF reasoning or just reasoning. And so now I want to map the string data that comes out of my OntoRefine project. I want to map it to this triple. Well, this is quite easy because I can directly interact with my data out of the graph. So out of the service clause, I can directly interact with what the data I have in a knowledge graph. So I can say, okay, concept URI goes out label, and it was the keywords. Okay, so I can add a triple like this in the where clause, which again, I repeat what it does. It gets the value that comes out of the keywords column, and it looks for triples in my main knowledge graph, not in the OntoRefine project. It looks for triples that have the same value as an alternative label, and it will bind them to the concept URI variable, which I can then use here. And I'll use, let's say, schema about. I know it's not the right, but schema about conceptual. Let's see how this looks in real life. And here it is. So the blog posting about RDF reasoning is now attached to my taxonomy, to the right tag, to the tag that is about RDF reasoning, which is something quite interesting that I can do. And then, of course, once I'm happy with how this looks, I can just change this to an insert, maybe add a graph clause, depends on how what my setup is, what I want to have out of it. And then I just run this thing, and I have my data. So yes, I have my data, but I have only 44 statements. Why? Because here I said basically only add those statements that have a keyword that is a reference in one of my concepts. So I have to add an optional here in order to add the data for which I don't have concepts. And here I have my 3000 statements of very nice RDF in my GraphDB. Okay, so this was using the virtual SPARQL endpoint and federation, but now I'm going to show you another way to which I can interact with Ontotext Refine, which is also very useful. It's in cases where I want to automate the workflow. So let's close the GraphDB for now. We're not going to need it. And let's go back to the OntoRefine. So imagine the following setup. I have already set up my RDFization, my model, I know my data, and now I want to automate this and to make it applicable to a new dump which has the same format, which I will consume maybe once daily or once weekly. I'll download it from the website and I'll produce RDF out of it. I want this to be completely automatic. How can I do this? So first, remember we actually have two parts to the problem. First, we had some operations on the table itself. So we fixed one of our colleagues' emails. We want this to be repeatable. We created the mail to column. This one here, we created this column, which was not in the original data. We deleted some stuff. So these operations are actually stored by OntoRefine here. So when I click on undo redo, you can see I have all my operations here. And I also can access them in JSON format. So here we can see them in JSON format and see what do we do. Okay, let's see the author email column. We replace Joy with we selected it. What was it? We replaced it to this, and then this we replaced it to this. Okay, so we have all the operations that have been performed on the table, and we can actually export them, and we'll call them ops history, which is the operation history of the OntoRefine project. And we have a nice JSON file, yeah, I'll replace it, which encodes all our operations. And this will be applied to any table, any data that has the same format, so that has the same column names and has the same shape. The second part of the problem is the actual RDF mapping. So let's go back to the RDF mapping. And so remember, we have this we can access in SPARQL format. So we can get it here. And this construct query, we can actually use to apply in batch. This is how it works. We copy it and we save it in a file. Where is my Sublime text? So we save it in a file, which we'll call mapping SPARQL. And the only thing that we need to do is to remove the service clause, because remember my not so pretty diagram. So we're not going to work here anymore. We're going to work directly on the OntoRefine project. So we remove the service clause. This in a later version will make it a little bit easier. Now it's kind of clunky here, so bear with me. So remove the service clause. And we basically have our mapping as SPARQL. So let's save it as the mapping SPARQL file. And then we can use the Ontotext command line interface. So here I use, again, it's kind of weird because I use a Windows machine, but I have git bash because I want the Linux style command line. So this is why it looks like this. So where does the OntoRefine command line live? It's explained in the documentation, but we also have a convenient way in the launcher here to open the command line folder, which is here. So in my case, I just installed it stock with the default parameters, and it's in app data local Ontotext Refine app bin, and the command line is OntoRefine command. So I added it to the path, and I can do stuff like this. So let's see, OntoRefine define clean, not Onto, OntoRefine clean. Okay, let's see if it works. It works. So let's have a quick look at what all options are there. What can we do? We can create a project, delete a project, export, extract, apply. So basically, this is all the stuff that we did using the visual interface. We can do using the command line. What is we can do it using the command line, and we also have this function here, which is probably the most interesting one, the one that we use most of the time, which is kind of a shortcut that creates a project, applies all the transformation, applies the RDF transformation, and basically spits out the turtle on the other end. So let's see how this works. Transform help. Okay. What are the options and parameters that I'm going to use? So I need to give it a CSV file, which is my input data, obviously. I need to tell it where the URL is, which is, in my case, is here, is the default one. Tell the operations. So operations are, remember, this is the JSON file with the OntoRefine operations as they are applied in the UI. It's optional, by the way. We can also we can omit it if we don't need any operation. And a SPARQL query which contains the mapping. Okay, so how does this look in real life? So I have a I have it in my history. Let's clear it. Here it's somewhere in my history. Okay, here it is. So come on. Let me zoom in a little bit. Okay, so this is how it looks. OntoRefine command line transform. Here is where the app lives. This is the ops history JSON. This is the SPARQL mapping. This is the input data, raw input data, and let's see how it looks. And here is my output turtle. So here I'm looking at it using less, just to check if everything's okay. It's okay. And now let's just pipe it into output turtle file. And here we are. And let's see our output turtle file. Is it as good as the one that we produced using the? It is exactly the same one. So here we have the URLs look good. So this, again, remember, this is the column that we created programmatically. It's not part of the input data. Tags are split, images are split. So it looks very good and we are very happy. So this was it from my part. So I showed you where's my plan. So yeah, I showed you how we can use the OntoRefine to visually explore and clean the data, prepare it for RDFization. Then I walked you through the visual RDF mapping UI. So shows how in an interactive manner we can build the mapping and while checking if the result is as we expected, which is very important with RDF. Those of you who have produced RDF know how good it is when we can check and verify our work while we're doing it. And then I showed you how using the virtual SPARQL endpoint we can directly import the RTF into a GraphDB instance or another triple store. It's standard compliant. And I also showed you the command line interface, which is a way to automate the tasks and to basically apply the same transformations on a table with a similar shape. So that's it for me. I hope you have many questions and I hope you found this interesting. And I'll be happy to answer them.
Yeah, hi. Again from me. There were a lot of questions and maybe we won't have time for all of them. There was one very active participant, and thank you, Tobias. I think his first question that I wanted to ask, I think you kind of answered there at the end. It was about the automation. He asked whether it will be the cleaning that you did in the beginning of the demo. Would it be automatically reapplied when you re-export the source data from Press? But you actually showed this how you can automate that.
This is a very important step of the process. So again, we should know what we are doing, because the cleaning in OntoRefine can have many forms. For example, I can use some complex, very weird filter and then clean manually some values. We should be sure that this same process, if applied to a new data, will yield results. It's not magic, but if we know what we're doing, we'll apply the same procedures to the new data. Yes.
Okay, another question. Is it possible to build the mail to IRI using Grail instead of creating a new column?
Okay, you're very good. It will be possible, and I'm completely honest. It will be. It is not possible using the current tool because of a quite stupid. It's kind of a bug that we have. It wants to escape all the characters, and I cannot tell it to use the result from a Grail expression as a raw IRI. So I want to avoid having to explain that, but now that you asked the question, it means that you are listening very focused. You are very focused. So this is what's going on. So we're going to fix that in a further version. So the other workaround that was possible was to construct it using Grail in the mapping UI, and then in the resulting SPARQL, just touch a little bit the binding so that it doesn't escape the characters. Otherwise, the column at mail2 will be escaped and it won't look good.
Okay. Okay. Well, questions keep coming up, actually.
Cool.
Yeah, that's actually quite cool. Okay, can you think of any limitations of these Grail functions?
Well, it's like it's asking me for the meaning of the world.
Okay.
There are a lot of limitations. So Grail is a little bit, it's a little bit clunky.
Maybe give a little background on Grail, on the Grail functions then.
Grail is quite, it's quite advanced. You can do a lot of things using Grail. So let's see if I have it here. So you can look at the OntoRefine user manual, and here you have a Grail reference, and it tells you all the stuff that you can do with Grail. And there is quite a bit of stuff. You have a lot of string manipulations. You have even for each loops, slices. You can interact a lot with the data. Of course, it has a lot of limitations, but for this reason, actually, Refine. This comes also from OntoRefine. It's not something that we take credit for. Refine also supports Scala and Jython. So you can, let me show you, you can here use transformations, and instead of grep you can use Jython, and Jython means you can write your own functions in Python, and you access them here in the same way. So that you have the value that comes in as a variable, and then you write your own function, so you can do anything and everything. I've used it, for example, the last time I used this was to transliterate. I had some Bulgarian data that I was working on, and I wanted to transliterate from Cyrillic to Latin alphabet, and it's obviously something that I cannot do with grep, but I found a Python package that does this, and I used it using Jython, using this thing. So I encourage you to go have a look at OntoRefine grep functions and Jython and closure support.
Okay, another graph related questions. These expressions in the SPARQL construct query, are they specific, GraphDB specific? The graph expressions in the SPARQL construct query, yeah, are they specific to GraphDB?
Yes, so this is actually, it's not GraphDB. This is the, remember, we're inside the service clause. So this is specific to the open Ontotext Refine SPARQL endpoint. And this is how the syntax works. It basically wraps the grep expression in this this expression here. So I have to give it the row index on which row, then the grep expression, and then we have this magic predicate mapper grep, which binds the value of this expression here to this variable here. So this is specific to the open Ontotext Refine SPARQL endpoint.
Okay. Well, do we have time for a couple of more questions?
I'm okay. Just
okay, let's go. There's one about the data and the schema available for the people to play with, but I imagine the answer to this would be, I don't know. So the data and the schema that you were showing in demonstrating Ontotext Refine with, would it be available for other people to play around with, or no?
Well, we haven't discussed it. I don't think so. Yeah, sorry, guys.
Yeah, I would say the question to this answer is no, but maybe we should consider having like a dummy data next time.
There is dummy data on the Ontotext Refine documentation. So let me.
Yeah.
So Ontotext Refine documentation, you can go here. It's very well documented. Product documentation. And here actually
this is an internal project that we're working on, actually making a knowledge graph of our internal content. So yeah, this is the work in progress.
So see here, we have in the RDFI's tabular data, we have some dummy data which is available. So all this is actually a tutorial, and we have somewhere here is the link to the dummy data, which is something about restaurants in Amsterdam. Where was this schema? This is the schema, and somewhere here is the dummy data also that we can download. And here it says all the questions about the grep expressions, how they work, blank notes, handling. So there's a lot of stuff that I didn't show. We don't have all day, but everything's here, and we have some dummy data.
Okay. Another question: is it possible to add a sort order index when creating nested triples from for example, an author list? Like comma separated names in a table cell.
So you're asking difficult questions. So when RDF has one major drawback, it's a pain to do anything that has to do with order. So it's quite hard if you don't have the order materialized in your data. It's quite a mess. If you have it materialized, it will probably be as a parallel array, which is also difficult. I mean, there you have either to write some hairy grep expressions or to write some hairy Jython functions, because handling of parallel arrays is not easy. Actually, I have one here, which I didn't speak about, but in order to properly construct this part of the data, which are conveniently skipped, but you guys are calling me out to all the stuff that I hope that you didn't notice, which means that you're listening. So in order to construct this one, so a schema, the images, but to add the name of the image, here I actually have parallel arrays, which is quite painful to work with. So let me show you how this looks in the data. It looks like this. Where do I have more than one images? Here I have more than one. So see here I have like all these images here, which are, sorry, I have a panel. So the images here, see they're separated with a vertical bar, and I have their titles here. And so the first title corresponds to the first image, the second title corresponds to the second image, and this is a mess. This is actually quite difficult to use, and we have submitted a feature request to OntoRefine to have a function that does basically the equivalent of the Python zip function, which will make an array with a second separator and have them like in ordered in the right way, and then we can use the other split. It's quite messy. So the answer is it's difficult.
Okay. Well, I think we've put you through enough of trouble answering difficult questions.
Yeah.
And maybe since we're a little off time, time to close the session. There are a couple of more questions that I will pass on to Nikola, and we'll add the answers in the follow-up. Thank you. Let me say thank you to all of you who have stayed with us until the end. Again, you will get a follow-up with the recording and the answers to some of these questions. There will be a quick survey once you close this panel. Just a couple of questions that we wanted to get your feedback about the webinar, and whether you found it helpful and any suggestions of how we can improve the delivery. Okay, well, thank you, and thank you, Nikola, for
thank you for running this. Thank you guys for listening and for your attention, and see you next time. Goodbye for me.
Bye. See ya.